What is solar power and how do solar panels work? Before I get started, I want to thank Fluke for sending this rad little thing. This is a taupe tester. I'm gonna talk much more about this towards the end of the video, so make sure that you stay tuned because this is the coolest tester that you're ever gonna see. Power has to be generated from nature. So we don't actually create electricity. A lot of times people are like, oh, we're generating or we're like making electricity. All we do with electrical circuits is we take some kind of energy that's generated from some other means and we transfer that energy through conductors, through wires, into a load. So we've got the source where we're generating, let's say at like a utility company, we're generating mechanical energy. When that generator spins, it's a big magnet, so that energy spinning, we can hook wires up to it, and that motion and that energy can be transferred to the electrons inside of conductors, and it makes those electrons shake. So that electron shaking is what carries that energy through, but it's no longer mechanical energy, it's now changed into electrical energy, but it's the same energy. And then as it goes through to the load, if it's like a light bulb or something like that, we're transferring that electrical energy into light energy and it's changing forms. So the light escapes and that energy escapes as photons. Some of it'll probably escape as heat too. You know, if you get like an incandescent bulb or something like that, you're gonna feel heat off of it. So it might have two different types of energy that it converts from electrical energy into light and heat energy. So that's basically what electrical is. It's not created, it's just that we take some kind of thing. It can be falling water at a dam for hydroelectric. It can be waves crashing, moving back and forth. It's just a natural, consistent thing that we can rely on, that there's a change, there's like a movement or a motion. It could be steam that is rising that's causing a turbine to spin. It could be wind that's coming in that's blowing a turbine and making a turbine spin, and that's causing that rotation of the magnet so that we can hook conductors, you know, and the whole thing works. But we need something from nature. And so in the case of solar, we're using photons, we're using light that's coming in. A solar panel is taking in light energy, and that energy that's coming from the sun is electromagnetic. Each photon is an electromagnetic particle of sorts that carries energy with it. And as a little packet of energy, when it hits an atom, it is able to interact with other electromagnetic things, which are protons and electrons. So when this photon comes in and hits the atom, it moves the electrons, and that's what creates that motion. But since it's constantly a flooding coming in from one direction, it's constantly a pushing that's happening in one direction. Now, solar panels have solar cells, and the solar cells are made of two different layers of silicon. So one of the layers is going to be a little bit more prone to having an excess of electrons. The other one's going to be a little bit more prone to having a lack of electrons. And when energy hits, it allows a separation through these two different layers to occur, so we can get a difference of potential or a voltage. And so when more photons come in, they start to push these electrical charges apart and develop a voltage, so now current can flow. And then we have multiple of these cells put together for a whole panel, and you can actually daisy chain multiple panels together as well to get an even greater difference of potential and therefore a greater amount of current to flow through the entire system. I actually have a solar panel here. This is something that I go camping with. It's a little travel panel. Super small. It has a 60 watt output on it. So you can see each one of these is an individual cell. All of the cells are wired together in a way so that we can get about 60 watts worth of output when this is sitting in the sun. Now, one thing about solar panels is there's a lot of things that affect how a solar panel produces power and what the output of it is. If you got like the sun over there and this thing is pointing this way, obviously you're not going to get very much output on it. So the angle at which it faces the sun, there's an irradiance rating with solar panels, and basically how much irradiation is happening onto the panel affects the voltage. So the less irradiation, meaning if this thing's in shade or if it's not, you know, in the right location, there's not enough photons hitting it to produce whatever its rated wattage is. So that's one thing you need to consider. Having this thing pointing directly at the sun is super important. Another thing that affects it is the temperature. So every solar panel has kind of like a range of temperature, but you have to know at the temperature at which these panels exist is going to change the output as well. So it's going to affect your voltage. If If you've got too high of heat, it's going to produce less voltage. If you've got cooler temperatures, you're going to get more voltage out of it within a range, right? There's definitely a certain range to that, but you have to consider things like that. If you're in a cold environment or warm environment, you're going to have a little bit different output on these. And then, like we mentioned, pointing at the sun, there actually is a specific angle. So when people do these solar installs, they have to sit and figure out what the angle is to make sure that they're getting the most efficient input of photons onto these cells. So there's some things that can affect solar as well. Now, with solar that's installed in homes and businesses, typically commercial solar panels are going to be larger than residential solar panels. But when you install panels, we have to install multiple panels, right? Because you're only going to get a certain amount of power out of each panel. So they can only do so much work, but you can actually daisy chain multiple of these panels together and get a much greater output. So one way a lot of people will use solar panels is directly. Like for me, when I go out in the field and I'm using this thing, I've actually got little connections that I can hook up and I can directly power, like charge my cell phone or something from the power that's coming in here. So in real time, I've got photons hitting this. There's a excitation of the electrons inside that creates current flow inside of a device. As soon as I go like this and like hide the thing, it stops putting out any power. The other option is to use batteries if you want to store power. So that's another thing. If I want to have power at night, then keeping a battery and having this solar panel provide a way to charge a battery and storing all of that energy into a battery, I can save that energy and use that energy at night. So battery power, battery backup is a huge thing that's used in solar a lot. Typically in residential environments, if you're kind of doing like an off the grid house, you might have banks of batteries because that's your whole purpose, is like during the day, you're trying to collect all of those photons and put it all in batteries so that at night you can live, kind of like rainwater collection, right? Like they want to get every single drop of water into this tank so at a later time they can use it if they want to. Some people don't use it that way. Some people actually use it to power specific devices because they want to have a certain amount of utility power that provides maybe power to like their larger loads, like furnaces, water heaters, stuff like that, that actually uses a lot of power. But a lot of their smaller stuff, they might use solar. So they're actually just wanting to take that power that's converted into DC in the solar panel, and they might just use DC equipment and actually use that power. Another thing that happens is the conversion of DC to AC. So there's something that goes on the side of a house called an inverter. And when you've got a solar setup, if it's all DC power, we have to get it to AC power, right? We have to make that stream of direct current go back and forth and alternate. So this inverter can take a DC signal and change it into AC. And so that AC is what we would use to be able to actually use like vacuum cleaners and toasters and stuff like that. For thinking about like how much power we should have in each one of these panels, you have to think that generally, like, even this is like it changes, but you can kind of think of each solar panel that's like a 5 foot by 3 foot residential panel is around 300 watts. Now, again, it could be different. There could be more, could be less. The efficiency, all of that has an effect to it. But generally, think about that. If you were just going to install one solar panel on a roof, it gets you about 300 watts, which is nothing. You know, you could power a TV off that, you could charge your phone, stuff like that. But like a toaster to burn your toast is probably around 1,000 watts, give or take, maybe 1,400, 950, somewhere around there. But if you think of a toaster as 1,000 watts, that means that you need to have enough panels put together that you have an output of 1,000 watts. So that is why when you look up on people's roofs, you've got so many solar panels, because they might be trying to hit like 8,000 watts, 10,000 watts, 20,000 watts. So the kind of same logic that we would apply to a generator, we kind of have to apply that to solar as well. So if I'm going to have a generator at my house, if I have like a 200 amp service and I know I want to power like most of the stuff in the house, but like not at the same time, if power goes out, you know, I know that I'm going to be running at a limited capacity. So I just need to make sure that I've got enough availability of power to run enough things at the same time so I can live comfortably. So a lot of times we'll put like a 20 kW generator, and that's 20,000 watts. So that's like 1,000 watt toaster, you know, and it's like a water heater that's probably 4,000 watts. And if I do a dryer, that's 4,000, 4,500 watts, something like that. So you can kind of see what size, what capacity you need. The same thing is true for solar. So for solar, you have to think about, what do I actually want to use solar for? Do I want to store this? Am I trying to reduce the costs that I have to pay for my electrical bill? So I want to kind of like partition or apportion a certain amount of power to utility while still having some things on solar. Do I want to get a kickback from the utility company? Because the utility company has a certain amount of power, certain like megawatts of power that they produce, that they generate, and there's multiple different people that generate power that all tie into the large collective power grid. And so you can actually get paid money in a lot of places to take any extra power that you've generated, that you've stored, and dump that onto the grid. And these utility companies will actually pay you some sort of rebate because you're helping. You're kind of like taking the stress off the system by applying more energy to the grid. So there's a whole bunch of different reasons why you would do this, but in general, it's just a way for us to use nature to provide power rather than us having to pay companies to provide power. And that's always a good thing, right? Now, typically with testing PV systems, you have to have a multitude of different test equipment to be able to test and verify and do all of your visual inspections. So the coolest thing I've ever seen, Fluke sent this to me. This is the SMFT 1000. It's a PV solar kit. So when they sent this to me, I was like, I thought I was getting a solar tester. Like, what is this? But the reason is because it has multiple different functions, multiple different parts to it. So when we open this thing up, this is so cool. A Fluke bag is cool, right? Like, it's awesome. It's got the hard bottom on it, so it's like super durable, just as good as any other backpack out there. All of these are like hard. Anyways, love it. So this is the SMFT 1000. And this is the main tester. So let me go through each one of these. This thing has a whole bunch of different knobs on it. So there's kind of this standard for testing. It's an IEC standard that's used overseas a lot, but it's a way for people to have a standardized way of testing PV systems. And it kind of walks through doing a visual inspection, walks through these different markers of what needs to be tested. All of it can be done with this one tester. So you don't need to have multiple different multimeters and irradiation testers and stuff like that. All of it's in here. So to start out, this thing's got a visual mode to it. So it allows you to do a visual inspection, and it actually prompts you with all of the things that you need to check in your visual inspection. They wanted to make a tester that was so easy to use that like anybody, there's multitudes of people that are like coming into solar work. So this just walks you through everything, and it's customizable. So you can kind of change the parameters of certain things. But the cool thing is the knob's also designed to go in order in the test. So if you want to test specific values, there's a resistance or an R low test. So it's just regular resistance testing. It does polarity. So if you want to check the polarity of your terminations, you can do voltage polarity, positive and negative. It's got a VOC and ISC. So if you're trying to check your open circuit voltage or your short circuit current, you can go to that. There is a power AC and DC switch. There is insulation testing. So if you're doing resistance testing, sort of like megging, but it's not the same. It just does it different. If you want to check your IV curves to make sure that your benchmark power that should be produced from these things is actually producing and that there's not some kind of problems. If you're trying to, if you check these things to make sure that the expected output matches what your actual output is, you would use an IV curve. You can check your bypass diodes. So if you bypass diodes essentially just ensure that current flows in one direction and it blocks it from going the other direction. So a lot of those are installed, but you can actually check those on here, do continuity tests. And then the coolest thing is there's this auto feature. So you can put it in auto and it'll run the whole entire check for you. And it does have some customization to it, so you can change some of the parameters to it. But if you don't want to have to remember and think of every single thing that you have to do, it can do an auto check and prompt you with all of these parameters. So this just makes it super simple for testing, and it's all in one thing. Another cool thing about it is the save function. It'll actually, like a lot of big companies, if you're doing like a massive solar farm out in the middle of the desert, somebody's paying for that, right? So somebody's actually paying a lot of money to have all of this installed. So they're going to want documentation provided, or even if it's just like a large commercial install or something like that, a lot of these places want documentation that after an install, everything has been set up correctly. All of the power output is within engineered parameters and stuff like that. So this basically gives you like professional control to know every single thing that you could ever want to know about your solar system. The SMFT1000 even comes with a true test software, which allows you to manage data from installs and commissioning, quickly create inspection reports. It has IV curve analysis, pass-fail visuals, and it allows you to access data from the computer and visibly by client, site, or inspection. So there's no more guesswork in doing solar work. Fluke has solved all of our problems for us. Another cool thing, you don't have to change leads. You plug the leads in, it automatically changes everything within the tester. So it's just, you leave the leads, and I think that's really awesome. So that is the one main function of the tester. It also comes with this I100. It's an AC DC current, solar current clamp. It has this little zero adjuster, so kind of like a scale. You have to tear a scale, right, if you're trying to measure something. So you can adjust it a little bit to make sure that you have your baseline. That's really cool. So you just clamp this thing on. I like that they actually like thought to make it a clamp instead of giving you those weird little donut crappy things with the conductors on them. So this is actually like really quality. Love it. And then the last part is the irradiance meter. So this is the IRR2BT irradiance meter, and this is going to be able to hook onto the rails of the panel. So if you're on top of a roof, you hook this thing up, clamp it down, it sits at the same angle that the panels are at, and it tests the irradiance that's coming in, how much photon action you're getting on these panels, and it lets you know if you need to change the angle or anything like that. So this is a super, super powerful thing. All of this together, there's tons of different leads, right? Like inside of here, they have a whole reel of conductor that you can hook up for your green leads. They've got other options in here too. They've got multiple different versions of conductors that you might need. So this is your blue and your red. On this side, I think they've got some like alligator clips and stuff like that. So yeah, you've got different clips. So if you want to test with actual leads, like a normal multimeter, you can do that, or you can put alligator clamps on. You've got a whole bunch of different lead options in here. And they've even got on this side, which I love, if you want, you know, like carry straps, things like that. There's even a magnet in here. So for a lot of the different multimeters, some of you might know what these are, but it's a magnet. So you actually can feed this thing through. Make sure I'm doing it the right direction. And then boom, now you've got a magnet, so you can actually stick this to something if you want it to like stay in an area. A lot of different multimeters you can use this with, so like I love these things for just standard DMMs because I like to be able to hook something and like stick it on something so it's displayed right in front of my face. So that's the whole system. That's pretty rad. Like from here on out, it's a super specialized tool for super specialized work. But I think it is the best tool for solar. And really it's the only tool that you need from here on out. You don't have to have any guesswork or wonder where you're at in your visual inspection. You don't have to worry about forgetting values and things like that. It just makes everything super easy. It trains people, so if they don't really know what to look for, it helps with all of that. All of the menus in here have an info button on them, so you can actually get information on every single thing that you're doing. It kind of helps you. So not only is it just an awesome tester, but they've gone through the foresight of making sure that it's teaching you and showing you and answering any questions that you might have along the way. So Fluke, killer job. Thank you so much for sending this to me. So the main thing with solar power that you really need to think about is how it's installed and its efficiency. A lot of the solar panels out there are terribly inefficient. It's just, people are developing new technology, right? We're trying to raise the efficiency. I think the best efficiency that we've gotten in a solar panel is like 45% efficient, 46, something like that. Most commercial panels are at like 15 to 20%. So you can see that like the amount of energy coming in, what's actually getting converted into an output of power is very small compared to what's actually coming in. The okay thing about that is that it's a renewable source. The energy is always coming from the sun, so it doesn't really necessarily matter that much. But in terms of cost of install, if you've got 1 million panels just to be able to get the certain wattage that you're trying to hit to get an output, if you could reduce that to like 500,000 panels to get the same output, you know what I mean? The cost associated with an install is definitely better if we can get more efficient panels so we don't have to have as many panels. Great thing about solar is that these materials, there's not like moving parts that you have to worry about. So generally solar panels last for decades just because of that, because they don't have a bunch of things that are going to be going wrong or can go wrong, other than just little like weird mechanical things or, you know, conductors burning up, weird stuff like that. But generally it's a pretty reliable thing. So I hope that helped you. Please leave some comments below if there's anything else about this that you want to talk about, or if you're a solar installer and you have different ideas or thoughts, or what you think about this cool meter right here. Love you crazy people. Thanks for watching, and I'll see you in the next one.